Welcome to iLecture Online, and here's a method that you can use to solve or to find the inverse of a 2 by 2 matrix. Now, I explained before when we did the 3 by 3 matrix that there's actually two ways in which you can do this. So first we're going to do this by the traditional method, just the way we did the 3 by 3 matrix, which means we're going to rewrite this matrix as a matrix with a companion. And the companion of this matrix is going to be the identity matrix. And of course, in this case, since it's a 2 by 2, the identity matrix looks like that, with ones across the diagonal and zeros this way. And so what we're going to do is we're going to go through steps of rules to make this on the left side look like the right side, and what we end up on the right side will then be the inverse of the original matrix. So if we call this the matrix A, we're looking now for what we call the inverse of the matrix A. And that will be located here when we're done with the procedure. So how do you do that? The first thing you want to do is make sure that this upper left element is a 1. Since it's already a 1, we can leave it alone. We don't need to do anything there. If it wasn't a 1, we would take the whole row and divide it by whatever number that was. So since it's 1, we don't need to do anything. But now we want to get rid of this number right here. And the way to do that is to take the second row, which is where the 3 is at, and replace it by the negative of this number multiplied times row 1. So negative 3 times row 1, and then added again back to row 2. That will ensure that this becomes a 0. Of course, you must do the same with all the other elements in that row. So let's do that. Of course, the first row doesn't change. It's still a 1, a 2, a 1, and a 0. But now when we take negative 3 times the first row, that becomes a negative 3. Added to 3, that gives us a 0. Negative 3 to negative 2 is negative 6. Added to 4 is negative 2. So you have to do this to every element. So negative 3 times 1 gives us a negative 3. Added to 0 is negative 3. And a negative 3 times 0, since it's 0, nothing changes. This remains a 1. So now we have ensured that the first column is a 1 and a 0, just like what we wanted. Now we have to change the second column. And we always start with the number that has to be a 1 first. So since that now needs to turn into a 1, we're going to take the second row and replace it by negative 1/2 times the second row. So simply what we're doing here is taking the whole second row and dividing it by a negative 2. That will turn this into a 1. So let's do that. Of course, we're not changing anything on the first row, so that stays the same. The second row, of course, since this is a 0, that stays a 0. Negative 2 divided by negative 2 is a positive 1. Negative 3 divided by negative 2 is a positive 3/2. Negative 2 divided into, or 1 divided by negative 2 is a minus 1/2. I got my numbers turned around here. All right, so we're almost there. We have 1s and 0 here. We have a 1 there. Now we need to turn this into a 0. And the way we do that is we take the first row. That's where we want the change has to happen. Then we take the negative of the number that we're trying to change, so negative 2, multiply it times the row that has the 1 in it, which is R2, and add it back to R1. So if we take the negative of this number, add it to this row, and add it back in, this will become a 0, which is what we want. So if we apply that, let's see, what doesn't change is the second row. Nothing changes there. So it's 0, 1, 3/2, and negative 1/2. All right? Now the first row will change. Of course, since this is a 1 and this is 0, nothing changes here. That stays a 1, because negative 2 times 0 added to 1 is still a 1. But negative 2 times a 1 is negative 2 added to 2. That becomes a 0. Negative 2 times this, that will become a negative 3 added to 1. That's negative 2. And negative 2 times this becomes a positive 1 added to 0. That gives me a 1. And this here is the inverse matrix, which applies then that the inverse matrix, A negative, is equal to negative 2, 1, 3/2, and negative 1/2. Okay, so how do we know we did this correctly? Well, one thing we could do is multiply the original matrix times the inverse, and we should get the identity matrix. Or there's actually a second method, kind of an easy, slick method on how to find the inverse of a 2 by 2 matrix. So let's use that. So if the original matrix, and let's rewrite it here, if A is equal to 1, 2, 3, 4, then the inverse of the matrix is equal to 1 over the determinant of the matrix, and I'll show in just a moment what that means, multiplied times these two elements change. So I'm going to switch those around. So the 4 goes up here, the 1 comes down there, and then we put negatives in front of these, so -2 and -3. So what we did was we're going to reverse these like so, and then we're going to put negative signs. So negative signs in front of these two, and then we get the inverse matrix. All right? Well, you know that this not quite looks like this yet, but that's because we haven't found the determinant yet. The determinant of the matrix, of a 2 by 2 matrix, can be found as follows. So if we take 1, 2, 3, 4, the determinant is equal to the product of those two, the diagonals like that, minus the product of these two, 2 times 3. So this is equal to 4 minus 6, which is equal to -2. So since the determinant is -2, we plug that in here, and that means that the inverse matrix is equal to 1 over the determinant, which was -2, multiplied times the matrix, 4, -2, -3, and 1. So if we now multiply the determinant, or 1 over the determinant, into the matrix, I get the following. So -1/2 times 4, that gives me a -2. -1/2 times a -2 gives me a +1. -1/2 times a -3 is a +3/2, and -1/2 times a +1 is a -1/2. And that should be the inverse matrix. If we come back over here and check, we can see that's the exact same result. So we know, yes, we found the inverse matrix. So there's two ways in which we can do or find the inverse of a 2 by 2 matrix. We could use a traditional method by pairing it up with the identity matrix, then going through the rules to turn this into an identity matrix. What we have on the right is then the inverse of the matrix, or you could say the inverse of the matrix can be found by saying it's 1 over the determinant, which can be found like this, times the same matrix with these two elements reversed and negatives placed in front of those two elements. So, but just to make sure that we don't do this wrong, notice that this is something that was added and this was something that was done. So we simply reversed the two elements, we put the new negative signs in front of it, multiply times 1 over the determinant, which is found like this, and voila, you can also find the inverse of the matrix like that. All right, hopefully this helps you accomplish that on your homework. Good luck.